D means the difference between them for a paired sample. Okay. They're trying to reiterate that it's a paired t-test. So what you have to do is find the difference between them. It's typically like x1 minus x2 typically. So you're taking that first value, that's 7, and subtracting 5.
Okay.
5 minus 9 is minus 4. 6 minus 8 is minus 2. 7 minus 7 is 0. 5 minus 6 is minus 1. Now, the question is asking for the test statistic, okay? Kind of always got to know, like, what is it even asking for? So you have to put this information into L1, the differences into L1, and then you want to do a stat test. I think it's number 2. It's the t-test.
Okay.
But this time you're going to use data for it. So I will do the same thing, but I'm going to use my software over here, and we'll compare answers if needed. So grab that calculator, go ahead and put that in L1, and then we'll do the test.
Are you going to put the difference in?
You only want the difference in. You don't need the x1 and x2. If you put x1 and x2 in, you have to calculate the difference.
You put it in L3 though, right?
I would put the difference in L1. I wouldn't mess around with this data. It's a good question.
Okay.
Just because it's so easy to calculate, I wouldn't try to make it more cumbersome by, doing the having the computer do the calculation here.
You're going to go to t-test
Yes.
and then use data.
Yeah. Now, hang on. This is what's going on here. So, okay, I think the question is not correctly written because it's asking for the test statistic. And yeah, you're going to go to stat test. Number 2, I think, is the t-test, and use the data in L1. But you're going to find that this doesn't work. Because what's given here are these are the differences in the means.
Yeah.
And that's not what they're asking. They're asking for this test statistic, but what's given is the difference in the means, which is taking the average of method 1 and the average of method 2 and subtracting them, or taking the average of the differences. So if you take the average of the distances, it ends up being minus 1.
Okay.
So what I'm trying to explain is that they try to say, again, like, the question isn't written wrong. These are not because the t-test statistic is like minus 0.557, which is not here, which means that, and the numbers here are real nice, minus 1, minus 2, 2, and 0. That's the average of these differences. Okay, let's keep going here. 26. All right, 2 independent random samples are taken to test the difference between 2 means of 2 populations whose standard deviations are not known but are assumed to be equal. The sample size are N1 and N2. The correct distribution to use is the t-distribution with blank degrees of freedom. So the degrees of freedom here is N1 plus N2 minus 2. 25 plus 30 minus 2 is 53. That is not on your equation sheet. You do have to remember that for 2 sample is your degrees of freedom formula. All right, so 27 here, You're gonna like this question. It's asking you to determine the y-intercept of the regression equation. So this is where you put the data in L1, L2. Okay, and then you do the stat calc. I think it's number 8 for the regression,
Okay.
but you want the y intercept when you do this.
Do I use the A, B, or R squared or
So which one did you choose? Did you choose number 8?
yes?
So that's a plus bx. So this is the y-intercept. A is the y-intercept, b is the slope.
Okay.
So what is your a value?
47.6.
There it is. I've got the same thing here on my side as well. All right, 28. It's not really numerical, but kind of requires some explanation. So in order to test the following hypothesis tested an alpha level of significance, H0 mu less than or equal to 800, mu greater than 800. The alternative is usually what we care about. We care about the fact that there's some place over here in the right tail where we're going to get a p-value.
Mhm.
Okay, and that p-value is associated with a z alpha level. Okay, and we're interested in rejecting. So you reject if it's greater than or equal to the z alpha level. So if you get a z value over here in the rejection region, you're in good shape.
All right. Okay, and then
That would be this third one here.
okay.
All right, so 29 is like 27. We're going to do a regression again on it. So this time you got to find the slope. Notice that the x's and the y's are flipped. So you want to put the x in L1, the y in L2.
Okay.
It's just a way to be deceptive to make it unclear. I will do the same. See if we can. You want to delete out any lingering values as well each time.
Okay. And then once those are entered, I go to
Stat,
stat calc
calc, I think it's number 8.
number
That
8
gives the
again.
a plus bx. This time, because you want the slope, you want the b value.
-1.
Yes.
So how come you don't actually have to add a plus bx?
Because a is a constant, b is associated with x. They're not like terms.
Oh, okay.
The graphically, if you remember, the intercept is there and the slope tells you how much it's rising over running. All right, number 30.
Yeah. Sorry, 1 second.
Sure, yep.
You can keep going, Matthew.
Okay, got it. In lower tail hypothesis test, lower tail is important. P-value is determined to be 0.2. The sample size for the test is 41. The t-statistics has a value of, okay. This one's tough. This one's a little bit different. They're telling you the area in the curve is 0.2 and the degrees of freedom is 41 minus 1 and minus 1, so 40. This is where you have to go to that table again. And let me pull that up here. All right, so 40 degrees of freedom here.
Yeah.
You're looking at everything here in this row. And it's like, well, which one do you want? So the top of the table,
0.2.
we want 0.2. So, darn. So the way this table is constructed is the first column, or all these are for one tail. I don't want to tell you to do this then. You know, it's like you need to know that this, so it's not in your table. What do they expect you to do? All right.
The 0.2 is not up there.
No.
Yeah. At first I couldn't see the top of that.
Yeah. I'm trying to decide like what would be best to explain this.
Well, we could try and find something that is in between.
Well, you can
0.5,
use,
right?
yeah, well, it's got to be, no,
And
it's got to be
0.2.
it's going to be bigger. But notice they are, I mean, that value is there.
Mhm.
So maybe that is the issue. I don't know. I don't know why. I don't know why they're doing it this way, but they are. If you think the question will just be the same when you get the test, I mean, you just remember it's 1.303. If you
Okay.
want more explanation, we'd have to go to the calculator to construct the p-values.
It's okay.
All right. All right, so go back to 31 now. All right, a statistics teacher wants to see if there is any difference in the abilities of students enrolled in statistics today and those enrolled 5 years ago. Is this one sample or is it two?
2.
It is two. So that's a good start. That tells you it's a two sample something. And sample of examination scores were from today and from 5 years ago was taken. You're given the following information. Is it a Z or a T?
Z.
Z. And we're interested now in a confidence interval. So it's going to be a two sample Z, two SAM Z confidence. So if you go to your calculator, that's under stat, test, and then 9. Looks like it's 9. And then from here, you got to choose data or stats. This time it's stats because you have the stats. Sigma 1 is the square root of 112. Notice they're giving you sigma squared, so you got to take the square root to get the other value. Get the sigma. Then you need to take the square root of 54. That. The next one, it looks like it wants is x bar 1 is 82. N1 is 45. It's the sample size. X bar 2 is 88. N2 is 36. So this time you actually do want the confidence interval. You have to change your confidence interval though, your C value to 0.98.
Okay. Okay, I got 10, negative 10.652, negative 1.354.
Pretty close.
Rounded like down though on the answer.
Yeah. I mean, it's like, it's close enough for me. I wouldn't, I mean, it's not like there's another answer that's 10 point
Mhm.
minus 10.65 and minus 1.35. It
Yeah,
should be like that close. That should be your only like, wow, I can't believe they didn't round it right. That's the only kind of discrepancy you might see when you're doing this. But hopefully you're getting comfortable with the calculations. You're gonna be doing a lot of them
yeah.
on the test there. Okay, 34. All right, a regression and correlation analysis results in the following information. The sum of squares regression. So this is, it's all a formula. You got to be able to find it. So the sum of squares regression is, I'm gonna go find that on the formula. It's on the right side on page 2. It would be, here's one of them. So the sum of squares regressions is y hat I minus y bar squared. Do you have that? Is this the same?
Yes.
This hat is what makes them different.
Oh, I see.
It's very subtle, and that's why I'm asking, because it's so subtle. You don't want you to put that number in. That's wrong. So it's like, well, how do we do this then? Well, you got to go find a different formula for sum of squares regression. So we're kind of back to SST. Let me snip this in. Kind of back to this one. SST equals SSR plus SSE. You have the SSE value.
Mhm.
So if you had the SST value, you could then find SSR. So we need another way to find SST, which is given. Here's the way to find SST. It's the summation of yi minus y bar. And you could sit here and argue with me and you'd be right that that does not have a yi, but it should. So SST is the 1434. So you can find SSR by solving that equation, subtracting 505.98 from both sides.
The bottom answer, 928.
Good, really good. Okay. Do you feel comfortable finding these formulas? Do you think you'll be able to do that on the, the real test?
Just gotta make sure they match up, right?
Yes. Yep. You're going to be using your calculator a bunch. Here is another one.
That's
for you
again, though, right?
Yep. That's good that you noticed that, because that's the kind of thing you'll see on the test. L1, L2, they want the slope this time. So when you get A plus B X, they're looking for that value right there. So go ahead and enter that in, do the calculations, and see what you come up with.
For the sea level, do
You don't need the C level for this. This is a regression equation. Stat, calc, number 8 after you get the data in L1 and L2.
Oh, I just have data for L1. Oh, I did T interval.
Yeah, it's very easy to go and use the wrong thing, but if it
Yeah.
doesn't have like, if it's asking for sigma and you don't have sigma or something, you're like, okay, maybe I'm in the wrong place.
Yeah, stat test number 8. Yeah, I just have list 1 and frequent. C or and C level.
Okay, I'm not, I mean, we've done this like 5 times already today, so this is not good if you're still not able to figure out where we're at. Stat calc, you're doing number 8, linreg.
Okay, 1 second.
So it's not a test. It's stat.
Yeah, I have the data, quit, and then stat calc. Okay. I got it.
Okay, fantastic.
All right. 24.25.
Okay, and that's the value of B.
Yeah, that was A.
We don't want A, we want B.
Oh, shoot.
B is the slope.
Negative 1.5.
Okay.
Shoot. Okay, I got that now.
Notice both answers are there. They're gonna
Yeah.
both be there. You got to know how to interpret between them. All right, number 36. You're not getting the same values, so you got to recalculate, unfortunately. But what they're asking you to hear when they say the point estimate of y when x equals 2, they're asking for you to use the equation that you find to estimate it. So you have to go again, put this in L1, this in L2, and determine the equation. When you determine the equation, you're going to use this x value right there.
Okay, so I put the data in and then we'll go to stat 8.
Got it?
And then A plus BX.
Yes.
Okay. So I got, for A, I got 12, and for B, I got -2.
Like this, 12 minus plus negative 2x.
Yes.
Okay, so you're going to put that 2 value in for x. 12 plus -2 times 2. You're using the equation to determine the output. And you'll find that that is 8.
Got it.
All right, so 37. All right, this one says the following information was obtained from independent random samples taken of 2 populations. So they're telling you right there, it's two populations. That's a 2 sample. Do they give you the population standard deviation or not? Do you see the word population anywhere in this given information?
Yes.
Okay,
At the top.
with population equal variances. Unfortunately, that's not the given information. Like you're looking for what's here. See how this is sample? Sample means a t. If it was sigma, it would be it would be a Z. So I know that that number, that word is there, but it's like, it's got to look for it down here in the table. So if you go back and look like at a previous problem we did, see how sigma squared was given? That's what you're looking for Z. If nothing is given, if it says sample, sample is always T.
Okay.
All right. So you're looking for a 2 sample Z or T interval. So that's going to be stat, test. Not sure which one is. I think it's probably 9 or 10, 9 or 0. Let me go look here on.
So can I put sample 1 in L1?
No. The L1 and L2 are just data, just the data, never the summary. These are summaries of the data.
Okay.
The table is meant to mean that it's a summary. All right. So stat, test. It looks like it is 0 this time. And you have your choice again between data and stats. And you want to choose stats because the summary table is the stats. So you need X bar 1. Your X bar 1 is 45. Your X bar 2 is 42. Your SX1 is 85. N1 is 10. SX2, that's, oh, I'm sorry. They're giving you variance. They're giving you variance here. So you have to take the square root of that 85. If you ever see the word variance, you know that you're going to take a square root. SX2 is the square root of 90. N2 is 12. And this time, though, you want to choose C equals 0.95 for the confidence interval.
And then N2.
N2 is 12. Like always think of the one, the sample 1 where the first row is, that's always going to be all your 1s. The next column here is going to be all your 2s.
Okay.
All right. So make sure you got that data entered.
And then where does the 95 go?
Should be keep going down. Should be a C confidence.
I don't know why I don't see C confidence.
Are you doing a 2 sample T interval?
Nope.
Let me snip that in here. 2 sample T interval. Is that what you see at the top?
No, I had the wrong one.
Okay, yeah, and at the end, that's a good indicator. Okay, if it's not there, that means that you've got to go find it because it's,
Yeah.
Even though what you're doing will give you something, it's not what you want.
Okay. Okay, it's the second option.
You're saying you got these numbers here minus 5.37 to 11.37. Okay, good. All right. Are you, it may feel like there's a lot of places we've been going. It's only really a few places. It's L1 and L2, maybe L3.
I need to just focus on on what I'm doing on the calculator.
Yes. All right, number 38 here. We're going back to regression formulas. If as a way to maybe help here, I would do like all the SSE problems, SSR problems together. I wouldn't try to keep going back and forth. I think that could be another
Confusing.
Yeah, like I would, if you see it, do all the ones with with two of these together, then go do all the ones with regression stuff. So this one's asking for the sum of square error. Again, the sum of square error, you go to the formula sheet and you're like, all right, well, maybe it's there. And this time, sum of square error is the yi minus y bar squared, y hat squared, which you do not have. You don't have. It's like, thought I had it. Nope. So you have to do it another way. The way that you typically do it is the SST equals SSR plus SSE.
Mhm.
And this time they're giving you SSR 104. So if you can find SST, you can solve for SSR, or I'm sorry, SSE. So SST is in the table. It's the 1974. You're going to subtract 104 from both sides. And 1870 is SSE.
Okay.
A lot of extra information, a lot of things you don't need.
Yeah, those ones are kind of hard.
We've done it. Yeah, we've done a few variations on this, so make sure you look at those again, so that you okay, here's where the formula is. Here's what I'm looking for. All right. All right. 39. All right, the 98% confidence interval for the two population means, so we got to go back and look here. The following information was obtained from matched samples. Whenever you see matched samples, you want to think paired. Paired means to take the difference between them.
Mhm.
If it were a lot of between method 1 and method 2, or sample 1, sample 2. So
Okay.
you can think of subtracting in here. But this time we want what's called a confidence interval. Paired always leads to a t-test. But because you want a confidence interval, you're looking for the t-interval.
Okay.
So that's stat test. Stat test. Yeah, that sounds right. And
Data. Right.
you got to put the data in. We should have done that first. That goes in L1. You could put it in L3, but L1 is probably a good place for it. Choose data. And you do have to change your C level this time to
98.
0.98. Good.
I got. Let me see. I got the answer. Okay, it's the first option. Oh, wait, no. The third option.
Yeah, make sure they're both there.
Okay, yeah, I got the third option. All right.
Sum of squares regression, sum of squares total. That's how you calculate R squared. We've looked at this equation a bunch.
Mhm.
The relationship between all these is SST equals SSR plus SSE. For this to equal 1, SSR has to equal SST. And the only way that's true is if SSE is 0.
Okay. Okay.
All right, now I'm gonna go back and I guess start at 1. You may have to tell me.
I kind of looked them up like right
Okay,
when we got past them, so
okay,
um I think I could go ahead and submit it.
all right.
Let's see. Okay, I got a 90. It's pretty good.
All right. So
It doesn't tell me what I got wrong though. So, oh wait, yeah, it does.
let me know if we need to go back and look at any of them.
Yeah. It looks like I just got a couple of the word problems wrong. I mean, I'm pretty happy with a 90.
Good, yeah. I mean, hopefully the exam is the same grade or better, right?
Yeah.
Okay, we got some time left here. What else would you like to have us look at?
On Friday, there's a micro assignment that I could look at.
Okay, let me go back to your dashboard here. I'll scroll down to Friday. And I see homework 12. Does that look right to you?
Yes.
Okay. No time limit like that. All right, so start snipping in some questions here. All right, assume that QD equals 80 minus 2P and QS equals 2P minus 20. So just graphically here, we've got 80 minus 2P going down and this other one coming up like that. And let's say the government imposes a price ceiling at $15 in this market. What is the loss in producer surplus? Okay. These don't seem right. Prices on this axis. So we have to actually resolve these for P in both cases. So for the first one here, you're going to resolve that for P. So we've got, let's see here, 2P equals 80 minus Q. P equals 40 minus 1/2 Q. And it looks a little better here. That's what we expect anyway. And then the other one, same thing here. We got 2P, when you're solving this one, 2P equals 20 plus Q. And then you divide by 2 there. So you get 10 plus 1/2 Q. So it looks like that. And what I typically do here is I think it's good to calculate the producer surplus, which I believe, I don't know, I can't remember. Let's not say it. Do you remember the producer surplus is in the top or the bottom?
I'm
I
not sure.
gotta look it up here. So I haven't done one of these in all semester.
This looks like one of the more difficult homeworks that I've had the whole year.
Yeah. So consumer surplus is up here, producer surplus is down here. So you got to find the area of that triangle, and then we can impose the price ceiling and see if there's an issue. There's also the possibility that's D because it depends on where the price is. So we probably should figure out where these intersect first. So let's set them equal to here. 80 minus 2P equals 2P minus 20. 100 equals 4P. P equals 25. So the equilibrium price here is 25. If you impose a price ceiling at 15, that is going to be problematic because it's below there. And when it's lower in this case, you really want to charge more than that, but you can't. So it is binding. So that's not the case there. So we have to go back now and find the area of this producer surplus triangle. Okay, so to do that, we know that this is 25. We know that it starts at 10, and then we got to find the equilibrium quantity here. To do that, you put the 25 for the price back into either equation, and you end up getting 30 for the equilibrium quantity. So the area of this triangle is 1/2 the base. The base is 25 minus 10 times the height 30, which ends up being 225. Okay, and then we have to figure out, well, what happens when you cut it with this line right here. So what that does is it changes the base, and then it also changes this quantity. So we've got to get this new Q value here. You get that from putting the 15 back into the line that goes up. This one here doesn't look right. Oh, I'm sorry, we got put in the wrong equation. Okay, so we put 15 here on the P value, 10 plus 1/2 Q. When you solve for Q, you end up getting 10. So instead of being 30, it's 10. So your new area of the triangle is 1/2 15 minus 10. That's the base here. The height is 10. So it looks like it's 25. So it went from 225 down to 25. The loss in producer surplus is the 225 that you had minus the 25, which is 200.
More steps to that one.
Yeah, a lot of work there. So 2 is a graph. Let me know if you want us to look at that. 3 is a graph with some numbers, kind of.
Yeah, whatever you think.
Okay. All right. We'll look at 5 next. All right. A current equilibrium is down here at 11 and a little bit above 10. So I guess we'll say 11 as well, roughly. So a price floor. So that when you set a price floor, it depends whether it's above or below the equilibrium.
Mm-hmm.
So the binding one is above. This one's binding. You probably heard that in class. It's binding because you really want to charge less than that, but you can't. Like the market dictates it should be down here, but it's binding because when it's up here, you can't charge less than that, and you really want to. The one below it is not binding because even though you can't charge anything less than that, the market's up here, so you would never charge anything less than the market, even though this one's down here. So you have to remember these two situations. For these apply to floors. For ceilings, it's reverse. There's 2 types of problems you'll see. So for a ceiling, it's just the flip of this. This one on the bottom here is binding. The one up here is non-binding. So that's just a separate problem for you to think about. We'll look at it later on. So it's binding if the price is above. So 16 will be binding. 16 will be binding. So those are your 2 possibilities. It's binding if it's above. And then we got to figure out, well, what's the surplus? Okay. So the surplus, if it's above here, how do we figure that out? Well, if the price is 16, actually, I didn't draw that very well. It should be up there. If the price is 16, suppliers want to make 16, but the demand is only for 6. So the suppliers want to make 16. The demand is only for 6. 16 minus 6 is 10 units. Let's go back and look at 3 maybe. All right. In this market, a minimum wage of $2.75 is. So let's go look at where it's supposed to be. It's supposed to be at $5. So you and I run a business and we want to pay everyone $5, okay? But the minimum wage is 2.75. Okay.
Mhm.
Is that an issue here? Well, it's an issue if the wage is up here, because we don't want to pay them 7.25. We only want to pay them 5.
Yeah.
But if the market, if something in the economy says you have to pay them 7.25, this is a problem. Okay. And think of a problem means that it's binding. But if the minimum wage is down here, this is not a problem. We're just good employers. We want to pay our employees more than they are, guaranteed by the government. And that in that case, it's non-binding. So in this case, because the equilibrium wage is 5 and the minimum wage is 2.75, which is down here, it's okay. We're just good employers. Okay.
Uh-huh.
So it's non-binding. It's non-binding. And because we're at the equilibrium, we're in good shape. There's no labor shortage or unemployment. Shortages occur when it's binding
Mhm.
or surpluses. Shortages and surpluses come from binding situations. All right, I'm just trying to figure out if there's another good numerical problem here. Let's do 10. 10's one we've kind of talked about, so it should be somewhat familiar here. All right, so it says consumer surplus before trade is before trade. So the surplus triangle is always this one on the left, and it's always cut in half. So the top is consumer surplus and the bottom is producer surplus. So you're, in terms of like what it's asking for here, when it's asking for consumer surplus, it's asking for the area of this triangle here.
Mhm.
So that's 1/2 base times height. Your choice, which one you do the base on. Typically I use the base, which is maybe odd, but it's always, this one's always kind of nice to do for the base, in my opinion. That's 26 minus 14. The height is the width, is the way I think of it. You're welcome to switch these, but 26 minus 14 is 12. Half of 12 is 6. 6 times 600 is 3,600. Now after the trade, it changes.
Mhm.
And we don't have to figure that out here, but that's something to think about here.
Okay. And
All right, number 11. Number 11 here. Okay. Equilibrium price and equilibrium quantity without trade. It's always where the two curves intersect. So price is always along the Y, Q is along the X. Don't know why, but that's the way they do it in econ. Don't understand it, I should say. So 42 and 1200. All right. All right, let's look at number 13 maybe. All right, number 13 here, total change in total surplus in Nicaragua because of trade is. So the way that I'm reading this is, I don't want to do this. I'm actually not sure. So let me find another problem that we can do a little bit better. I'm just looking at another problem here, see if I can answer it or if it's gonna, I gotta look them up. Sixty times 40. No, 40 times 900. It's not right. $100. Okay, that's not making sense. All right, let's look at 19. All right, so question 19 here, if the government imposes a quota of 14, price of the import is, they're basically saying like you cannot do more than this.
Oh,
Okay, but the problem is we know that at that quota, the supply price is 14 and the demand price is 8. All right, but this is a problem because we it's not at the market equilibrium. Market equilibrium is at 11 and 11. So the price has to adjust here. So it adjusts to the demand side here, which is 8, which is not one of the answers. Oh my gosh. Okay. This isn't going well. All right. I suggest we stop here. I would need to actually spend some more time looking at these to give you much more help. Most of these are in the category of consumer surplus, producer surplus, taxes, trade, a little bit of review, and most of these can be answered pretty quickly, but a lot of them are going to be about you create like these sort of wedges where like there's tax revenue, and then your consumer surplus changes, your producer surplus changes, things like that. These are all available online as far as I remember, but leave that up to you. So
okay.
let's go ahead and stop here for today.